Solving systems by substitution, part 1. One method that we can use to solve a system of equations is through substitution. So one of the essential questions to ask is, how can I do this? And how do I know if I need to solve using substitution? Well, we use substitution to solve a system when at least one of the equations has the x or y by itself on one side of the equation, or could be easily manipulated to have such. An example of a problem: y equals 3x minus 2 and 3x plus 2y equals 14. To solve this problem, I can take the 3x minus 2 and plug it in for the y value in the second equation. Hence, the 3x minus 2 can be plugged in for y, and it makes my second equation become 2x times 2 plus the quantity, or 2 times the quantity, 3x minus 2 equals 12. Once I've plugged in, now I solve for the variable, in this case for x. So I'm going to distribute, and I'm going to be left with 2x plus 6x minus 4 equals 12. I'm going to simplify and get 8x minus 4 equals 12. Add 4 to both sides and get 8x equals 16. Divide by 8. And I'm going to find that when x is equal to 2, these two equations are going to be equal to each other. Now, to find out what the y value is that goes along with this, I take and I plug the 2 into one of the two equations. It does not matter which one you plug in for. I'm going to plug into the y equals 3x minus 2, and I have y equals 3 times, well, my x value is 2, so I'll plug it in. And 3 times 2 is 6 minus 2, y equals. So I should get that y is equal to 4. My solution then, the point at which these two lines intersect each other or are the same, is when my x value is 2 and my y value is 4. And if I want to double check this work, I take the original other equation and I plug in this 2 and the 4 to find out if it gives me the correct answer. So the original equation was 2x plus 2y equals 12. And I'm going to plug in the 2 for x and the 4 for y. I'm going to get 2 times 2 plus 2 times 4. And if this is the correct solution, then this answer should come to 12. 2 and 2 is 4, plus 2 and 4 is 8, and 4 plus 8 should equal 12, which it does. So I have a solution, an ordered pair, that satisfies both equations. Well, what if both my equations are already solved for a single variable? Then what do I do? Well, we can do what we call making a choo-choo train. Since they're both saying y equals, in this case y equals 3x minus 2 and y equals 5x minus 8, if I know what y is equal to, and in this case the first one's equal to 3x minus 2, I can plug it in for the very first y in the second equation, and I get an equation that says 3x minus 2 is equal to 5x minus 8. At this point, I'm able to go and solve the problem. So I'm going to solve for my variable. I do this by combining like terms, and I'm going to bring the x's all to the right-hand side. So I'm going to subtract 3x from this side and subtract 3x from this side. And I get negative 2 is equal to 2x minus 8. I'm going to add 8 to both sides. I'm going to add 8. And we're going to get 6 is equal to 2x, divide by 2, divide by 2, and we're going to find that my x value, where these two equations are the same, is when x is 3. So my second step is to plug this back into one of my original equations, and one of my original equations was y equals 3x minus 2. So I'm going to plug it in, have y equals 3 times 3 minus 2, and 3 times 3 is 9, minus 2 is going to be equal to my y value. So my y value is equal to 7. And I can test this by taking the other equation, which was y equals 5x minus 8, and plugging the 3 in, and I'll get y equals 5 times 3 minus 8, and 15 minus 8, and y equals then 7. So in both cases, when I plug x as 3, I get y as 7. So my solution, the point where the two equations are the same, is when x is 3 and y is 7. Alright, now to practice a couple problems. So in this case here, we have y equals 2x plus 1 and 2x plus 4y equals 14. I have one equation that's already in y equals and another equation that's in standard form. In this case here, I'm just going to plug in 2x plus 1 wherever I see y in the second equation. I see it right there. So I'm going to plug in and I'm going to get 2x plus 4 times 2x plus 1, and that's going to be equal to 14. I'm going to work my problem out, and I'm going to get 2x plus 8x plus 4 equals 14, which gives me 10x plus 4 equals 14. Subtract 4. I'm going to find that 10x equals 10. Divide by 10. And we're going to find that x equals 1. We take that and we plug it back into the original equation, and my original equation was y equals 2x plus 1, so y equals 2 times 1 plus 1, which is 2 plus 1, so my y equals 3. I'll test this in the second equation by plugging in both the x and the y value. And I'll take, my second equation was 2 times x plus 4y has to equal 14. I'll plug in the x value of 1 plus 4 times the y value of 3 and hope that it equals 14. And I have 2 plus 12, and 14 does equal 14. So the ordered pair 1, 3 is the solution. It's the ordered pair that makes both equations equal to each other. Alright, so let's try one more. In this problem, we have x equals negative 2y minus 12 and 4y equals x. Now in this case, I know what x is. I know what x is, and I know what x is. So therefore, I'm just going to set them equal to each other, and I'm going to get the equation that 4y equals negative 2y minus 12. And if I solve for y, I add 2y to both sides. I find that 6y equals negative 12. Divide by 6. Divide by 6, and I find that y equals negative 2. Now I'm going to take this negative 2 and plug it back into one of the equations. I'm going to take it into the 4y equals x. And when I plug this in, 4 times negative 2 equals my x, and 4 times negative 2 is negative 8. So negative 8 equals my x value. And now I'm going to take this and I'm going to plug this into my other equation just to make sure, and the other equation says x equals negative 2y minus 12. So I'm going to plug in negative 8 has to equal negative 2 times negative 2 minus 12. And negative 8 has to equal positive 4 minus 12. And positive 4 minus 12 is negative 8. So this works in both equations. So therefore, my solution is negative 8, comma, negative 2. I hope this helped. Now you need to complete practice worksheet number 1. Thanks.